Okay, let's quickly go over how to convert between atoms or molecules and moles, and then between moles and grams. Okay, now I've written this chart up here to try to help you outline, kind of sort your thoughts out and know what sort of conversion you're looking at. These things are really easy to mix up. So if I'm trying to convert between atoms or molecules, these tiny little particles, and moles, which is the main unit we use in measuring a lot of chemistry quantities, the conversion factor is up here. 1 mole is always the same as 6.02 times 10 to the 23rd particles. Now I say particles, that could be atoms or molecules. Even though they're not the same thing, mathematically you're going to treat them that way. This is just the definition of a mole of anything, okay? Just like a dozen donuts represents 12. A dozen eggs represents 12. An egg and a donut are not the same thing. An atom and a molecule are not the same thing, but the amount of them, if there's this many particles, 6.02 times 10 to the 23rd, there is 1 mole of them. Okay, so there's our conversion factor for this transformation. Now, if we're trying to go from moles to grams, which is mass, we're going to be using the molar mass from the periodic table. Okay, and that's the atomic mass that you see for each element. Now, this is just a quick refresher on how to set these up because it's real easy to kind of get them confused. So the first question here says how many moles is equal to 1.8 times 10 to the 24th molecules of CO2. So when I see this, I see molecules, okay, that's a type of particle, and I'm looking for moles, I am making this transformation right here. Now whatever direction I'm going, that's a one-step conversion. I'm going to begin the way I've done a lot of my conversions. I'm going to take my measurement that I have, which is right here, and I'm going to include the units. 1.8 times 10 to the 24th molecules. And it's really helpful if you don't write M, or especially M-O-L-E, because it's going to really confuse things. I'm just going to write out what it is. I have this many molecules, and I want to turn it into moles. Okay, moles is what I'm actually after. Okay, so I'm going to do a one-step conversion, and on top, I'm going to put the units I want to get, what I'm trying to achieve. Remember, we did this with a lot of units you're used to. Now it's some units you're not used to. Molecules, it's going to change to moles. Okay? So on top, I have what I want to change. I got the transformation I want to make. Once you do this, the problem's essentially done. All the decisions have been made. You just have to now fill in the blanks and get the mechanics to work out where you put in the correct numbers that match with the correct units. We know from our past problems that if we have molecules right here, we're just going to drag it down to the bottom because we want molecules on top and molecules on bottom, so they'll cancel out and they're no longer there, and we have units of moles left over. Now we have moles and molecules. This is not something that a lot of people would have in their mind and remember always what that means. Okay? But here's our definition of 1 mole of anything, is it's right there. 1 goes with moles, so I put 1 where moles is. Happens to be on top this time. Sometimes it'll be on the bottom. It just depends the direction you're going. And then I've got 6.02 times 10 to the 23rd. And that's all I have to have. What I'm going to do mathematically, though, this is the part where a lot of people mess up. I need to make sure that my calculator recognizes that gigantic number. So I'm either going to use scientific notation or I'm going to type it in exactly the way it looks, but then I have to divide by that entire number. Okay, so parentheses are really important here. If you don't put parentheses in, your calculator is going to think you're taking this number, divide it by 6.02, and then it sees that times 10 to the 23rd. It thinks that's a separate number and it moves it back up top. Okay, you don't want that to happen, so you need to use parentheses around the bottom number, especially in this case. Okay, most calculators, if you don't use parentheses, is not going to interpret it the way you want. So I just take this number, divide it by this number, okay? And on your calculator, some of you have a scientific notation feature, and if you're using like an iPhone or something, that may be tough to come by. Just depends on what you're used to. So I'm going to take 1.8 10 to 24 divided by okay, now make sure you're typing this in the way you expect to have it. I'm going to do parentheses, 6.02 times 10 to the 23rd. Okay, now I'm typing this in exactly what I'm telling you. Take this whole number, just the way it looks, divided by this whole number in parentheses so that the calculator knows that's all of the number on the bottom. That's all of what I'm dividing by. I hit enter and I should get a regular size number. This should come out to be about 3 moles of CO2, carbon dioxide. Okay, now if you get an answer that says something like 3 times 10 to the 47, you've got a problem with how you're typing it in the calculator. You need to practice that and figure out how to make your calculator do what you intend for it to do. Okay, this does get a little tricky with these gigantic numbers, just in the mechanics of using one of these. Now comes the part that's easy to calculate. We just have to make sure we interpret it accurately. Okay. This says, what is the mass? Okay, now remember, mass is measured in grams of 2.9 moles of propane, which is C3H8. Look at your measurement. That's moles. I'm right here, and I'm trying to get to mass, which is right here, grams. That's another one-step conversion. So I'm just going to write out a one-step conversion using this as my beginning point. 2.9 moles of C3H8. It is really important you recognize what that is. Like, you don't just put moles of anything. Everything weighs something different on the periodic table. I'm going to do a one-step conversion and try to turn that into grams. Okay? I want moles. I have moles. I want mass, which is grams. I've made all the decisions there are to make. I just got to fill in the blanks now. I know moles is going to go down here. Okay, so I take moles and put it down here. And I know it's C3H8 that I'm working with. Okay, 3 carbons, 8 hydrogens. Now, let's take a look at what we have on the periodic table, molar mass. Okay? If I look up carbon, carbon has a mass of 12 grams. Okay, that's its molar mass. So you see an atomic mass of 12. There's also 3 of those. So carbon contributes 36 grams in this particular compound. 36 grams per mole. Hydrogen, it has a mass of 1, but there's 8 of those. So it contributes a mass of 8 grams. So I'm totaling this entire thing up. The whole compound, all the components that go into it, I add those together and I get a total mass of 44 grams per mole. Now, anytime you look on the periodic table and you add up a mass, it's telling you the mass of every 1 mole of everything on the planet. So the periodic table is set up to find the mass of 1 mole of any substance. So anytime you look on the periodic table for masses, your corresponding value is going to represent 1 mole. Always. Periodic table shows 1 mole of everything. 1 mole of propane is 44 grams. Okay, now this time 44 ended up on top because that's where grams was. If I was doing a conversion and grams need to be on the bottom, 44 would end up on the bottom. You have to let the units dictate where things should be. The numbers match the units go where they need to be in order to get the correct meaning. Okay. Moles is on top and bottom, it cancels out. The only thing I'm left with is grams of propane, C3H8. So in this case, I'm just going to take 2.9 times 44 because they're on the top. Okay, in the previous problem, I had to divide because 1 was on the bottom. Okay, so I take 2.9 times 44, and I get 127.6. Now, what does that mean? That means grams of propane. That's all that's left. And that's just a couple quick examples to remind you of how to convert between atoms and moles, or molecules and moles, and between moles and grams. You can go either direction with these. You could even go 2 steps and go from grams to moles to atoms. But basically, you only need 2 conversion factors. You need the definition of a mole, and you need the molar mass from the periodic table, depending on what substance we're working with.